Hey folks, Mr. Dell here. We are looking at using exponent rules and writing them without negative exponents. So this is coming from CPM's course 2, course 3, and this is from the closure questions. So closure specifically 9-158. It says simplify the following exponential expressions, give answers without negative exponents. So if I look at uh, 4 to the negative 3 times 4 to the positive 7. Well, I have like bases, right? So, and I know I've got some rules I'll write over here, some exponent rules. One of them is x to the a times x to the b is equal to, I should say x to the a plus b, right? When you're multiplying like bases, x to the a, x is some exponent times x to another exponent is equal to that same base, but add the exponents. So in this case, it's 4 to the negative 3 times 4 to the 7th, the base stays the same, and I would add the exponents, negative 3 plus 7. And so that would be 4. So 4 to the negative 3 times 4 to the 7th is 4 to the 4th, because I can add those, a negative and a positive, which really you subtract, and there's more positives. So it's 4 to the 4th. If you want to work that out, 4 times 4 times 4 times 4 is 256. Okay. B. Now, B, my rule here, if I notice I've got a power to a power, that rule is x to the A all to the B. When you have a power to power, you take those exponents and you multiply them. It's x to the A times B. So here, first of all, this is 5, but it's 5 to the first. There's no exponent on it. So really what that is 5 to the third, right? This parenthesis with the 3 out here says that all of that is to the third power. So even the 5. So the 5 was to the first, now it's to the third. It is x to the fourth, but according to my rule, I would make it x to the 12th because it's a power to power. When you multiply power to power, you multiply the exponents. So if I clean this up, 5 to the third means 5 times 5 times 5, which is 125, x to the 12th. And that's as simplified as possible. All right, here we have c, which is 3 to the 7th divided by or over 3 to the 4th. So there's another rule. This rule would be to say that if you have x to the a all over x to the b, so if I'm dividing like bases, that equals x to the a minus b. You actually subtract the exponents. When you divide like bases, you subtract the exponents. So I have division of like bases, so this would equal 3 to the 7 minus 4. I subtract the exponents, which is equal to 3 to the third, and 3 to the third means 3 times 3 times 3, or 27. Another way to look at this, though, is I want to make sure you see that, is if you forget these rules, you can always write them out, right? So 3 to the 7th means that I'm going to be multiplying 3's 7 times. And then on the bottom, I'm going to multiply 3's 4 times. So what I can see here is I can see some division, right? I can divide out some giant ones here. I can see that a set of 3's divide out there. Another set of 3's over 3 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1. So if I look to see what's left, I have a 3 times 3 times 3 all on the top and just a 1 on the bottom. Whenever anything gets canceled out, it's still a 1 there. So that's why this becomes 3 to the third. 3 times 3 times 3, or 27. Okay. This one here, if I look, I've got exponents, but I got exponents on these variables, but not a power to a power. It's not like what we had up here on B. So this is just all multiplication. This means 4 times x to the 5th, then times 3 times x to the negative 8. So I have all this multiplication. And when you have multiplication straight across, you take what you can multiply. So I can multiply these coefficients. The 3 and the 4 multiply to give me 3 times 4 is 12. And then also the x have like bases, and we go back to this rule over here. When I multiply like bases, I add the exponents. So this becomes x to the 5 plus negative 3. 5 plus negative 8, which is negative 3. So those end up there. Now the thing is x 12x to the negative 3 is an answer, but it's not completely done because it wants no negative exponents. So remember, one more rule, when I have a negative exponent, see if I can find a place for it. I'll put it here. If I have x to the negative a, that means 1 over x to the positive a. When you have a negative exponent, it creates a reciprocal. It flips that around. The reciprocal is the flip-flop. So when it's negative, it goes to the bottom and becomes a positive, right? What's also true, and I'll just put it out there, is if I had 1 over x to the negative a, if my denominator was negative with the negative exponent, I should say, then that would flip it up and it would become a positive on top. So either way, it's a reciprocal thing. It's a flip-flop. When you flip it around, the exponent becomes positive. When you make a reciprocal, reciprocals create positive exponents if they're negative. So that being said, this right here is now 12 times 1 over x to the positive 3, right? So it creates that reciprocal. The exponent becomes positive. And if I want to simplify that further, I can, because I can just multiply these two straight across. That 12 now, I'll put it over here, is in the numerator, and the x to the third is the denominator. So there's my answer. 12 over x to the third. Okay? There we go. That was 27. Make sure I have all my answers circled there. 26.